have actually seen quite a bit of this already. So it's not like this is completely new for us. We've been using it quite a bit. So recall, the integral from a to b of f of x dx equals the area under the curve from x equals a to x equals b and the x-axis. Now this is where a is smaller than the b value. Something I want to point out to you is I have never ever said that area is negative. Okay, area is not negative. However, what I am saying, the integral can be represented by a negative. Okay, when you are looking at that region below the x-axis, the integral can be negative, but area is never negative. So I just wanted to be really clear with that. So here we go. Let's run through some properties. If I have the constant multiple property says, if you have a constant times a function, you can pull the constant out if you find that to be convenient. The additive property of integrals, if you are adding two functions, you can separate it into two integrals that you're adding. Here's another really cool one that we're going to see a lot today. If c is a number between a and b, I can split the integral from a to b as a to c plus c to b. Okay? We've also seen this one. If I have the integral from a to a of f of x dx, that's 0 because there's no area. And then this one we've been using. If I'm on a closed interval from a to b, but I have an integral from b to a, I have to switch the order, and then it's the opposite of that integral. So let's take a look at example 1. If I want to evaluate from 1 to 3 f of x plus 6 dx, and I'm given the integral from 1 to 3 of f of x dx is 10. So I'm going to use properties here. And we're given the integral from 1 to 3 of f of x dx is 10. And I want to pause here a moment before I finish this one. Do you understand that what is inside the integral is f of x, or a y? So if I have y equals 6, what is the graph of y equals 6? It's a horizontal line, right? So watch this. If I'm really looking at y equals 6 from 1 to 3, I know how to find that area, don't I? So anytime you have an integral of a constant, you can represent that by creating a rectangle. So that's going to be 2 times 6. So 10 plus 12 is 22. All right, letter B. Evaluate the integral from negative 2 to 5 of the quantity 3 times f of x minus g of x d of x. And I'm given those definite integrals. So the first thing I'm going to do is I'm going to pull my constant out. And I'm going to split the subtraction of the f of x and the d of x, or g of x. Okay, so let's take a look at what we've got here. I've got the integral from negative 2 to 3 of f of x dx, and I have an integral from 5 to 3 of f of x dx. Any ideas how we might tackle the integral from negative 2 to 5? Because I don't have that one like I have for g. What could I do? Yeah, something like that. So let's look at that. So let's go from -2 to 3 of f of x dx. But do you see I don't have 3 to 5? So I'm going to have to do minus and flip that one. And then we know g of x was -4. So do you understand that? I had to flip the limits of integration. So then that's 3 times the quantity, 6 minus 3. So that's 13. So this is how you can use these different properties. So anytime you see an integral and the lower limit is bigger than the upper limit, you're going to have to switch them and negate. So let's look at special circumstances with functions. If you look at the figure to the right, I have two regions that are labeled capital A. From 0 to A, the integral from 0 to A f of x dx is equal to A, but the integral from A to B of f of x dx is the opposite of A. So that's an integral representation of that area. So we've been using that. Then here are some important functions. If I give you the graph of f of x on the left, okay, this one, can you tell what graph that is? Sine, okay, this is the sine of x. If I take f of negative x, that means this is an odd function, and you can see that it's being reflected about the origin. And something that's interesting here is that if I look at, if I knew this area, okay, and as it gets reflected, and I'm going to do this below, if you have an odd, whoops, wrong, I wanted the highlighter, there we go. If I have the integral from -a to a of f of x dx, whoops, sorry, I shaded the wrong thing. So here's a below and above, there we go. That's what I wanted. So I'm like, that didn't make any sense. So if I'm actually looking at the sine of x, and I know sine x is an odd function from pre-calc, then you have equal areas above and below, just like I have up above there. The other thing that's interesting is if I go look at the third one, and I look, and let me come back here, if I go, say, from -pi to pi, oops, this is not my even and odd, sorry. Woo. So here we go. If I went -pi to pi, and I have an even function, then do you see that that is just twice the area of A? So notice what you can do here. When you have an even function, and I have the integral from -a to a of f of x dx, we can actually do the integral 0 to a of f of x. I just need to go from 0 to a and double it. Even functions, if you remember from pre-calculus, are symmetric with respect to the y-axis. So we're not going to see this in example 2. We're going to look at it in example 3. Let me give you a short head start, and I want you to try example 2. Yeah, exactly. Yeah, try example 2 on your own, and let's see. All right, in letter A, I pulled out the 3. And I'm going to pull out the 5. So this is 3 times 18 plus 5 times negative 8. Did you get 14? Yes, good. All right, then in letter B, what's the problem with this one? Yeah, they're backwards. So we're going to put a negative out front. And if it is as straightforward as this one is, you can jump here. And I got negative 26. You will see some of these that get a little bit more complicated. You have to really write more things out, but that one's really straightforward. All right, try the multiple choice for me. Try this one. This is a common multiple choice style question. All right, talk at your table. See if you got the same answer. Oh, sorry. All right, I got letter B. Did we get that? So let me show you how you do this. It says you're given the integral from negative 5 to 2 of f of x dx is negative 17. The integral from 5 to 2 of f of x dx is negative 4. What is the value of the integral from negative 5 to 5 f of x dx? All right, so in this one, what I know is the integral from negative 5 to 5 f of x dx is going to be equal to the integral from negative 5 to 2 f of x dx plus the integral from 2 to 5 of f of x dx. So this is negative 17, but do you see this is in the wrong order? So I need to flip it. So then that becomes, and you could do my plus a negative negative, however you want to do it. You could have also negated here, said minus, and that's all okay too. All right, in example 3, assembling areas. So it says you've got the integral from c to 0 is 3, so let's put that one in there. I'm going to, again, give you a few minutes head start on me and do as many of these as you can figure out in example 3 from A to F. Yeah, can you just have us here, take this, and you can use a scientific calculator.
You have a box of them.
Yeah, they're right there. You're also going to notice in the notes, I put a QR code. I actually got this example and the next one from another APC Calc teacher. And he provided this where he does an explanation, because I know E and definitely F are really, really challenging. And he does a beautiful job explaining, even though I will explain it, maybe hearing it from a different person might help. So I went ahead and included those two little, they link to his YouTube explanations. Really fabulous. All right, so letter A, if I want to go from 0 to e, the integral f of x dx, that is just negative 7 plus 10 equals 3. How many of you got that? Give me a show of hands. You got it? All right, we're in great shape. Now, if I want to go b to d, that's negative 5 plus 3 plus negative 7. That's negative 9. So if you've done these two, you have the basic understanding. Like you are understanding integrals. So now, C through F, we're gonna go up C and D a little bit. E and F, sort of like 3. You're scoring a 3 on the exam if you got A and B. You're going to get C and D, you're going to score a 4, and if you get E and F, you're going to get a 5. It's really sort of how this goes. So let's look at C. What does it mean when you take an absolute value of your Y values? What does that do to your Y values? It makes them positive, right? So from A to 0, this is going to be 15 plus 5 plus 3. It's going to take this lower piece and flip it up, okay? So, yay! What's the difference then in letter D when I put the absolute value on the outside of the entire thing? So you do your integral and then take that answer and make it an absolute value. So let's do that. So from A to 0 would be 15 plus negative 5 plus 3. Absolute value of 13 is 13. All right, here we go. We're going all the way up to the 5s. So in letter E, I have the integral from negative e to e of f of the absolute value of x dx. And I want to scroll back up here a moment. And this is representing the even function. And it's getting reflected across the y-axis. So here's what's going to happen is I know what 0 to e looks like. And I'm going to sketch, and I'm going to ignore the A, B, and C. I don't want that. I want it negative E to E. So let me show you this. So here is, this is 0 to E, but if I reflect this across the y-axis, this is what the integral of f of the absolute value of x looks like. So that is going to give me 10 plus negative 7 plus negative 7 plus 10. That's 3 plus 3, so that is 6. Show me hands. Did anybody get there? Woo! Woo! That's awesome. That's awesome. Okay. All right. Let's see. Let's go. Let's go. 6 for 6. Let's go. So if I have f of negative x, remember that is a reflection about the origin. So I want negative c to negative a. So let's make a sketch here. And here's my, yeah, I'm not sketching that very nicely. Okay. So this one, I don't think I'm drawing this really well. Try that again. So if I'm doing this about the origin, it's going to go like this. There we go. That's terrible, but so here's my negative C to negative A. So, and do you notice that the limits of integration are not backwards? These are not backwards because negative C, okay, think about A and C, it's not saying that A is positive. A is just some number. So clearly A is a negative number and C is a negative number. So when I do negative C, negative A, this is the proper limits. Okay, this really is the proper limits of integration. So then when I go to do this, it's negative 5 plus 15, which is 10. Anybody get that? That one was a really, really tough one. Okay, nobody got it? Okay. So again, do you see the QR code? I strongly recommend you listen to it again with a a different person saying just what I said, but sometimes that helps.
So is the negative x reflected as the y?
Not it's not over the. It should be over. This is odd, right? So yeah. So think about it like this, that if I have f of negative x, and if you look at the previous page, that is, the graph is a reflection about the origin. So can you look at that middle one right here? I mean, it sort of does look like it's going across the y. But when you have an odd function, I like to think of it like this. If you, oh, that's a terrible drawing. So think of y equals x cubed. It's where you take it and you rotate it about the origin. And so what I do is I look at it upside down and it looks the same. I know that when you look at it, it looks like it's flipping across the y, but technically that is not what's happening. So, all right, let's look at the last one. What about integrating a function with a discontinuity? So if I want to evaluate from 0 to 5 of f of x dx, where f of x equals negative 2x plus 7, when x is less than or equal to 3, and f of x is 4 when x is greater than 3, we're going to sketch this, shade the region that's depicted in the definite integral. Well, I know this piece is pretty easy. 2, 3. I'm going to go up to 4, and that has an open circle at x is 3, and that's a horizontal line. So we go all the way back to Algebra 1 to do some of these pieces. Then negative 2x plus 7. So this is a line with slope negative 2. So I have two regions. One is a trapezoid, and the other one is a rectangle. So what's really awesome is even though I have a discontinuity, we can apply the meaning of a definite integral here because I have defined regions. So my integral from 0 to 5 of f of x dx would equal I'm going to do a trapezoid. The height is 3. My parallel bases are 1 plus 7. And then I have 4 by 2.